To create a new project, click on Launch on your engine version of choice. For this tutorial, we'll be using version 5.1. In the project browser, we have a wide variety of templates that we can choose from. If you can't see the window on screen, you can click on Games from the left side panel. From here, select Blank as your default template. At the bottom of the browser, we can see where our project will be stored locally. If we look to the right, we can see that we can rename our project. I think I'm going to go with My First Tutorial. When you finish renaming, click Create at the bottom of the page. When we first get into the editor, what can we identify? In the center, we have our main viewport. From here, we can navigate, manipulate objects, and preview our game in real time. If you're used to Unity, this is the same as the scene and game view combined. On the right, we have the outliner. Here, we have a list of all the objects in the current level, providing a convenient way to select, organize, and manage various actors and assets within the scene. If you're used to Unity, this is the same as the hierarchy view. Underneath this, we have the Details panel. In here, we can edit the properties and settings of a selected object, such as its location, rotation, scale, and many other components. This is also the same as the Inspector view in Unity. In the top of our page, we have our Play toolbar. From here, we have quick access to play our game, advance a single frame, stopping the simulation, and switch into editor mode whilst playing. The main difference for Unity users is that there's a button to view the editor mode while in play mode, instead of a separate game view. This is due to the real-time rendering capability found within Unreal. In the bottom left, we have our Content Drawer. From here, we can view all the assets that's contained within the project, such as models, textures, and even blueprints. Next to this is our output log. The output log is a panel that displays messages, warnings, and errors during our development process. Using this will help you troubleshoot issues within your project. Unity users will find that this is the same as the console. And finally, we have our command prompt. Using this will allow us to interact with the system and execute various commands, scripts, and programs using typed commands. Now that we're familiar with the interface, let's get started by creating a new level. To do this, click File at the top of the editor. From the drop-down list, click New Level. From the new window, select Blank as your default template, and then click Create. Now that we have our new level, let's create a new folder for organization. To do this, click on Content Drawer at the bottom, then click Add, and now New Folder. Once created, rename this new folder to Maps. Awesome! Now, click back into File, and then select Save Current Level. In this new window, we can rename our map to whatever we like. I'm going to go with Demo Map. Then, double-click into your Maps folder, and then click Save at the bottom of the window. Great! We've now created and saved a new map for us to play around with. The next thing we need to think about adding is a character controller. Unfortunately, we're not going to be looking into creating a controller in this tutorial, but what we are going to do is look at how to import one from the base templates that's built into Unreal, to quickly get started with prototyping. To start with, let's click the Content Drawer. Then we'll click Add, and select Add Feature or Content Pack. From here, we have a variety of templates to choose from. For now though, let's just select the third-person template, and click Add to Project. From here, we don't need these new windows, so just close them down. For a useful shortcut, we can press Ctrl and Space to open up our content browser. As you can see, importing the third-person template has added a bunch of new content that we can use in our project. Clicking into the third-person folder and then the Blueprints folder will allow us to see the player model and game mode that we've just added. In order to quickly use these assets, let's click on the Blueprint icon at the top of the editor. From here, click on the World Override Game Mode, and then select the base class and find the third-person game mode. If we click on the play button at the top of the editor, we'll see that we can now use our third-person character controller. Awesome! But what is it that we've just done? Currently, we've swapped the default game mode of the level for the one that we've just imported in the third-person template. A game mode blueprint defines the rules, logic, and core gameplay elements for a specific game or level. This includes player spawns, character controllers, and even win and loss conditions. If we're going to learn Unreal, we have to be able to create our own game modes. So let's get to it. Back in the editor, press Escape to leave play mode. From here, let's head back into the content browser. Click on Add, and then select Blueprint Class. From here, we have a variety of blueprint types that we can choose from. For now though, let's just select Game Mode Base. For this game mode, let's rename it to BP_tutorial mode. The glaring BP at the start is just a way for us to easily tell this is a blueprint for when we're looking through the project later. If we double click on the new mode, we can see the blueprint and all of its classes. Don't worry though if your screen is different to mine, as you probably have the data only version of this blueprint open. You can open the blueprint in the same view as me if you click on the Open Full Blueprint Editor option at the top. On the right hand side, we can see the default pawn class. If we click into this, we can select our third person controller from the drop down menu. When you selected your character, make sure to compile and save your blueprint at the top left of the editor. If we close this window and return to the editor, we can now select our game mode to be the default for this map. Just as we did before, click into the Blueprint tab at the top, click on World Override Game Mode, select Base Class, and find the new tutorial mode we just created. Great! Our level is now using a custom game mode that we've created, but that's not all we can do here. If we closed our project and reopened it, this level wouldn't be the default map that opens first, so let's fix that. Head to Edit at the top of the editor, and go to Project Settings. From here, if we look to the left, we'll notice the Maps and Modes tab. To start with, let's change our default game mode to the one we've just created. Next, let's change the startup map to our demo map, and then the default map to the demo map. Great! Our project now recognizes our custom mode and level as default. If we head back into the project and press play again, we can check that our player character still spawns with the new settings. As always, let's organize our project by adding a new folder for the game mode. Click on Add, New Folder, and call this folder Blueprints. Next, drag and drop your mode into this new folder. Select Move Here, and just click OK on this message box. If we hold right click in the scene, and use WASD to move the camera into the sky a little, we should notice that if we press play, the character is actually spawning into the world at the location of the editor camera. If we click onto the Content tab at the top of the editor and go into the Basic tab, we can see that we can add a player start object. Using the arrows gizmo, we can alter the location of the start position. Just make sure it's not underneath the level. And then if we click play, our character will now be in the position in which we set the spawn. Awesome! Now, let's focus on adding a ball for our player to kick around. If we click onto the Selection Mode tab at the top of the editor, and then click on Modeling, we now have a panel that allows us to add in objects. If we click onto the Sphere tab, and move our cursor into the viewport, you can see that we can now place a sphere into the scene. After left-clicking your sphere into position, head back over to the Radius variable in the Modeling tab. For now, we will set this value to 20. After setting the radius, click Accept in the main viewport window to add your sphere. After adding the sphere, head back into Selection Mode at the top of the editor. If we click play, you'll notice that if we try and walk into the ball, we collide against it. In order for us to move this ball with our character, we'll need to add physics. Let's start by heading to the Details tab. If we click onto the static mesh component on our ball and scroll down, we'll find the Physics tab. In this window, make sure to select Simulate Physics, and then select Mass. If we click play and try and collide with the ball again, you'll find that we still can't move it. If you escape out of play mode, you'll find you'll be greeted with your first error. This error message can also be found in the output log at the bottom of the editor. If we scroll up, you'll find our error message highlighted in orange. As we can see, the error states that the ball is trying to simulate physics, but it has the wrong type enabled, so let's fix that. If we double click on the static mesh object, a new window will open. If we click on the collision tab at the top of the editor, we can add a new simplified collision for our sphere. From here, head over to the Details tab and look for the Collision Complexity option. In this drop-down menu, make sure to select Use Simple Collision as Complex. Great! Make sure to save this ball before you leave. Back in the editor, if we press play and try to collide with the ball again, the player will now be able to kick the ball around. Great! As you can see though, the ball is able to move faster than the player and won't slow down. If we head back into the static mesh component for our ball and go back to the Physics tab, we can change the linear and angular dampening values to solve this. I'm going to go with a value of 0.5 for both. If we head back into play mode, you'll find that the player can now keep up with the ball. Awesome! Now, let's add a custom material to the ball so we can change its colour. Right-click in the content drawer and select New Folder. We're going to call this folder Materials. Click into the newly created folder, right-click again, and select Material. We're going to call this material M_ball. If we click into this material, we can see the main material node in the center. In order to change the color of this material, we need to feed in some values. If you right-click in the graph and type in constant, you'll be able to select the constant vector 3 node. A constant node represents a fixed, unchanging value. In this instance, we can use a vector 3 to represent the red, green, and blue values. Once you have the node in the graph, drag the white constant node into the base color of the material. From here, if you click into the black color window, you can select any color that you wish. For now, I'm going to go with a nice purple. Next, let's try to add a metallic look to our ball. If we right-click in the graph and search for constant again, we can add in a constant that represents a single value. From here, we can hook our node up to the metallic option, and then set the value to 1. If we select our constant, we can duplicate this by pressing Ctrl and D. We can then hook this node up to the roughness option. Set the value to 0.5, and there we have it, our new material. Don't forget to apply and save before exiting.